We're going to use our newly made Audion in this old radio. This one I built back in the mid-90s and made it to be very much like what you would have seen in 1912. Okay, here we have here we have our grid capacitor. It's a piece of dowel, and it has paper and tin foil wrapped around it in 2 layers, giving us a capacitance of 400 picofarads. And then across it we have our grid leak resistor, and it's a piece of dowel wood, and it's got a piece of paper that has pencil written on it. Take the regular lead pencil, and that was scraped on there until we got a resistance of 2 megohms. And that's how they would make a high value resistor back in those days. You couldn't go buy one at the local Radio Shack or anything. Okay, now, okay, this is the output bypass capacitor. This goes across the headphones, and it's made the same way. We take a piece of wood dowel, and we wrapped paper and aluminum foil and made 2 layers of it, and the total is 2,200 picofarads. Okay, now to adjust the filament, we've got a nice homemade rheostat here. It just some nichrome wire wrapped around a piece of cardboard, and then that's bent around on a form. It's machined out of Bakelite, and I used the parts out of a more modern rheostat to make it just, you know, You couldn't get a tuning condenser back then. You know, back in 1912, you couldn't buy these nicely made variable condensers we have, so we had to make a variable condenser, and this was done by soldering plates. Piece of shaft was machined with slots in it, evenly spaced, and 2 pieces of it were made, and these plates are soldered into it, and we can vary that to maximum capacitance and minimum, and that gives us our tuning. Now for the coil, this is an anachronism. However, it's exactly the same as it would have been made. I just happen to have one. We've got a variable coil that has the antenna connected to it, and then our main tuning coil on the outside. This could be used to make it into a regenerative set, but right now we're just using it as an antenna tuner. Okay, and if we look at it from the front, okay, we have our connections for the antenna and the ground. I don't know why this is tangled up in here. There we go, some antenna connection. And then we've got our tuning and our rheostat for the filament, and our output. And then this switch here selects the impedance of the antenna coil. So you can set it down to where it has very, very weak coupling, gives a very sharp, high Q tuning, and then you can increase it up to have more and more turns, and that makes it to where it'll go ahead and give more gain, but not be as high a Q. For the output, normally this goes to a headphone, but I can't demonstrate a headphone on YouTube. I don't know how to get that to where you can hear it. We'd have to put a microphone on it as the amplifier or something. Instead of the headphone, we've got a resistor placed in where the headphone would go, and that serves as the plate load for the Audion. And then that we have wired here to a small amplifier. This is made for amplifying crystal radios, and it'll work just fine for amplifying this. And we just have a gain, a variable gain from somewhere around 0 all the way up to about 3,000 or so full blast. And then for our sound, we've got us a nice horn speaker, so that'll be a little bit more accurate. And then power supply, we've got our lab power supply. Okay, now for the tube, okay, we've got the Audion that we just made a couple weeks ago, and it is, I tested it this morning, and it's good. It's still good. It has no traces of air at all. So it looks like it's well sealed. It ought to give quite a bit of time there, maybe a year or more. We'll just have to see. Okay, now we take the grid wire and we have to hook it to the grid wire we connect to our grid leak and condenser. Not getting it. Okay, and then the plate lead goes to our headphone connector. That'll do. Yeah, say hi to everybody. Say hi to everybody. Tell everybody you were sitting outside in a 97-degree heat and wanted to come into the air conditioning. It's terrible out there. Yes, it's hot out there. Okay, some of my junk has failed. You see here, we've got no connection to the filament, and we're reading a mistake in the wiring of this thing. This switch determines whether you connect the common of the filament supply either onto B minus or B plus, or actually connects B minus of this onto A plus or A minus. It turns out when you connect it to A minus, it shorts the damn power supply out. Oh, what did I do? What did I do? It normally gets connected to A plus anyway, so it doesn't matter right now. That's why I never noticed it until now. That's why I didn't put any schematic of this power supply out on the web. It's got so many errors in it. It just, there are so many errors in this thing that I'm just totally embarrassed of making the damn thing. Okay, we hook up A plus onto here, A minus onto here. Okay, let me turn the rheostat up. There we go. Okay. There we go. So we got filament, and I've got it set right now to 67 volts, and we got 2.2 milliamps. Okay. Now, okay. Okay, now, let's see. We're getting something. That speaker's not really much. They really had some trouble. I don't know what station that is. I'm not sure that this switch is wired correctly. It seems to be out of order. Well, it's that's it, using a spherical Audion. It's just a plain detector type of receiver. It's not regenerative. Looks like from 45 on, it doesn't make any difference for the gain. 45 volts B+. Okay, well, that's it. An old 1912 style radio, typical of what they would try to make back before they even knew how to hook up an Audion. This is one of the biggest problems DeForest had. Most of the people back then had no idea how to hook up an Audion. Okay, that's it.